This is Wolfgang of Mevas. Today we want to show you how to measure the undercarriage of a Caterpillar tractor and what kind of tools we use for that purpose. So we have various gauges for the purpose, and we have an option to use a so-called ultrasonic tucker. So those pins are movable, we can move them in and out. This is for cleaning, this is for measuring, and we have two caliper. And I'm going to show you now what we do and how we do. So the first thing, let's start with the trackshoes. When we measure trackshoes, we go approximately 1/3 to the inner side. So from outside, 1/3 in. We put the bar on, and then we move this pin in. We take it out and we measure. So we have the dimension of the trackshoes. This is the first step. Let's go to the sprockets. Caterpillar calls it also segments. This is because the sprocket is made of 5 segments. So if we want to measure the condition, we take a ruler and we put it from outside of the first tooth, 1, 2, 3, to the outside of the third tooth. And as we can see here, we have 212.5 millimeters. So that's the measurement for the sprocket. What you need to make sure is that you don't measure over the gap of 2 segments. You see here, this is here starts the next segment. So you just measure over 1 segment. Otherwise you have the gap and the value would not be correct. Let's take component number 3. This would be the track link. To measure the track link, we take again our bar. We put it exactly over one of the links, over the pin of the track link, and then we push again to the underside of the track shoe. So now we remove it and we measure, and we can see 121 millimeters. So we got the measurement of the track link. Another thing we measure is the diameter of the bushings. We have again the possibility to do it with the mechanical tool. So we take the caliper and then we move it, we open it in a way that it is slightly, smoothly going over the bushing. And we look again for the most worn position. So that's the measurement we take. And we have here 64.5 millimeters. And again, we can measure the bushings with the ultrasonic tool, which from my point of view is the more correct and the better way to measure it. So you move the probe slightly over the bushing until you can't see any changes in your display. In this case we see 12.25 millimeters. Next item would be the carrier roller. The carrier roller can be measured with one of the calipers. We take the caliper, we close it, and then we bring it in a position that it is just slightly gliding over the roller. And then we take again the measurement. Now it becomes a bit more complicated because we want to get information about the rollers. As you can see here, we have chuck roller guards. So the second and the last second roller we can't measure. Anyhow, the best tool to measure it is again our bar. To find the correct distance of those pins, we go back to the carrier roller and we put the bar just on the carrier roller to press through 4 pins. So as you can see here, they are placed in a way that they meet the surface of the carrier roller. Now we push them out, that they are far enough out, and then we go to the bottom roller. We move the bar in this way, and then we push the bar to the surface of the roller. We move it out carefully, and now we have to do the correction that they measure the distance from the surface, from the margin to the surface where the trucks are rolling. So you take a measurement and you take the average of all 4 measurements. So you see here we have 21.5, 23.5, 24.5 and 22. So you just calculate it together and build the average. And then you have the value for, this was roller number 1, 2, 3, 4. And we would do the same for all rollers we can access. So I show it again. We push the pins. We put the bar on the surface of the margin. We take it out. 4 pins are our measurement. So now it comes to the idlers. In this case it's a bit special because this is a so-called System 1 undercarriage. The System 1 undercarriage means that the idlers are running inside the chain. For measuring the idlers we have different options, and we use always mechanical tools. So the System 1 idler we measure in a way that we use the gauge, the caliper, put it on the surface here, and then we measure to this margin. So this way we see it is 16.5 millimeters. In case we have a conventional idler, we put again the bar on top of the idler, and we push the 4 pins on the most worn areas. So we push them to the ground, and when we have done this, we take the measurement and we take the highest wear. In this case we have 27 millimeters. Here it's 25, 25.5, 26. Here it's 27 millimeters. That's the value that we need. Once more we have a System 1 idler. Again, we use the caliper, we put it on the surface here, and then we screw it down to this margin. So you see it here, this is the point that we need. For the bottom rollers, we can also use this tool. As we have seen before, you can use the mechanic tool to measure the distance with the 4 pins. We can do the same with the ultrasonic tool. So again, we do a little bit of the fluid to our probe, and then we slide on top of the bottom roller and we look for the most worn part. So when you have it straight and your value is not changing anymore, you know that you have the correct value. This way we have measured all the components. Of course, we repeat this bottom rollers that we can access, we repeat it for the front idler. The last thing we measure is the distance, how far the cannon is moved out. This is the so-called cannon. This is to keep the track sack in the correct value, and you just measure the value that you get here, and you see it is 43 millimeters out. If you look to the Caterpillar handbook for the undercarriage values, you will find the allowed value for moving it out. And on a D5, for instance, if it is moved out approximately 9 centimeters, 90 millimeters, then you know some components on your chain are worn. But not least, we take the dimension of the truck shoes. We know it's 830 millimeters, which means it's an HEP undercarriage, that you can see here, which means low ground pressure. And there's one more thing we can do. If we don't know which kind of truck shoes we have in use, we can take the thickness of the truck shoe in this position. So, and this value would help us to determine which kind of truck shoes we have assembled to the machine, because there are heavy duty truck shoes, there are standard truck shoes, and for an HEP I think we have at least 3 different kind of truck shoes. So this dimension gives us the information which truck shoe it is, because the wear happens here and not here. So this value will continue all the same most of the time. For larger bulldozers we have a protocol where we take all the values that we measure, and then looking back to the CTS handbook, we can compare which value that we measured comes to which percentage of remaining life. And there's one important thing to note. If you looked at the CTS handbook, Caterpillar is talking about percentage worn. If someone is talking about machine condition, he is usually talking about remaining life. So you need to make the calculation. 60% or worn is 40% remaining life, for instance. That's an important point.